This video is about arithmetic shifts. What I've done is I've grouped arithmetic shifts and logical shifts together because they both perform similar functions. So what do? Well, they allow you to take a binary number, say like 0001, and multiply any binary number by one of these numbers. Okay, now what are these numbers? Well, what do they have in common? We can kind of classify these as powers of 2. 2 to the 3, 2 to the 4, 2 to the 5, and 2 to the 6. So what does arithmetic shift and logical shift do? They're systems to allow you to multiply a binary number by a power of 2. And that's it. But why would you have two systems that perform the same thing? Well, arithmetic shifts do it with signed integers, whereas logical shifts will do it with unsigned integers. And if you don't know the difference of these two, then you need to watch my video on that. So in this video, I'm going to concentrate on explaining arithmetic shifts, specifically doing multiplication and specifically doing on a positive number. Okay, so here's a binary number and I want to perform arithmetic shift on it. I want to multiply it by, let's go with 2 to the 1. Okay. So how do I do this? Well, first thing I'll do is write out the binary. Now this system uses the 2's complement system, and if you don't know the 2's complement system, then you need to watch my video on that. Okay, but using the 2's complement system, I can say that this is positive 1. Okay. So I'm going to write my binary down here, 0, 0, 0, 1. And what I want to do, I want to multiply it by 2 to the power of 1. Here's how I do that. So I write out the place values again. The first step is I take my MSB, and if you don't know what MSB is, you need to watch my video on that. I take my most significant bit and I draw an arrow and I drop it down there. That must be kept because the most significant bit tells us whether the binary is positive or negative. Second part now, well, what am I doing? I'm doing a multiplication. What does multiplication mean? It means a left shift. And how far am I shifting it? Well, this number here tells me how many places I'm shifting it. So I'm performing a left shift 1 place. Well, here's my 1. I'm going to perform a left shift 1 place. So that goes there. And I fill in the blanks, fill in the other place values with zeros. So let's go back to the beginning. Arithmetic shifts allows you to take a binary number and multiply it by a number that's a power of 2. Here I'm taking the binary number of 1 and I'm multiplying it by 2 because 2 to the power of 1 is 2. So 1 times 2, well, that should just equal 2. What have I got? Yes, this is the binary for 2. So that's correct. And that's it. Okay, so the steps are drop down the MSB and then shift the place values based on the power number, assuming we're doing a multiplication. So let's do another one. Let's say I now want to do 1 times 2 to the 4 is 4. 1 times 4. Okay, so again, write out the binary 0, 0, 0. Write out the new places, drop down the MSB, and I'm shifting it how many places? Well, 2. So let's put the right number there. So I'm shifting this one left 2 places. 1, 2. And then the blank place values get filled in with zeros. Let's have a look. Have I got the right answer? 1 times 4. Well, 1 times 4 is 4. And yep, the binary shows me that this is the binary for 4. So I've got that correct. Okay, so let's have a go with an 8-bit number. 0, 0, 0, 1, 0, 1, 1, 0. And let's say I want to multiply that by, I don't know, 4. Okay, so I'm using an arithmetic shift to multiply this signed integer by 4. So how do I do that? I'm going to write out the place values, 2, 3, 4, 5, 6, 7, 8. I know that 4 is actually 2 to the power of 2. So my shift value is 2. And I'm doing a multiplication, so I know that I'm shifting left. So I'm shifting my binary left by 2 places. This one goes 1, 2, there. This one goes from here 1, 2. And this one goes behind it. And then I fill in the rest of the zeros. What I forgot to say is that I dropped down the MSB, so I'm going to make that very clear. Drop down the MSB. And then fill in the rest of the zeros. Okay, well, how do I check this? How do I know if I'm right? What is this binary number? Because it's quite big. Let's see, I've got a 16. I've got a 16 and I've got a 4 and a 2. So 16 plus the 4 is 20 plus 2. So this is binary number for 22. Okay, so this binary number is 22. 22 times 4. Well, that's quite easy. That's 88. 22 times 4 is equal to 88. So what's this binary answer? Is it 88? Well, let's have a look. I've got a 64, I've got a 16, and I've got an 8. And let's add these back up together. So 64 plus a 16 is 64 is 10, 6 and 1 is 7 plus that 8, and add on the 88. So 88 plus the 8 is 80 plus the 8 is 88. So yes. So this binary number for 22 times 2 to the 2 or times 4 is equal to this binary number, which is 88. And that's it. Remember, the most important steps are drop down the MSB, for multiplication, shift left, using the power number to tell you how many left shifts you do. Now, there is one limitation to this. I'll just quickly go over that now before we do some example. Before you grab a pen and paper and have a go at these. The limitation is this. Let's go with 0, 0, 1. No, let's go with this. Sorry. 0, 1, 0, 0. Now, if I wanted to do a left shift on this, well, the first thing I would do is obviously drop down the MSB. And then I'd have to left shift that one, but I can't because the MSB needs to stay there. So we bump into one of the limitations of this system. Okay, grab a pen and paper. I'll put some examples on here and then get ready to press pause. Okay, so let's go with 0, 0, 0, 0, 0, 1, 1, 0. And we'll multiply that by 16. 0, 0, 1, 1, 0, 0, 1, 1, and we'll multiply that by 2 to the 1. And 0, 0, 0, 1, 1, 1, 1, 1, and we'll multiply that by 4. Okay, so grab a paper and pen, have a go at these, press pause on the video because here come the answers. Okay, so I'll do these in a different colour. Let's go with orange. So 16, well 16 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is 2 to the power of 1, 2, 3, 4, 2 to the power of 4. Okay, so that's my shift. So I'm shifting these by 4 places to the left. So 1, 2, 3, 4, that goes there. 1, 2, 3, 4, that goes there. And then fill the rest in with zeros. Okay, let's have a look at this one. 2 to the power of 1. Well, I've already got my shift value, so that makes it easy. And I'm left shifting by 1 place, so that goes there, that goes there, and that one goes there, and that one goes there. Fill in the zeros. 4, well 4 expressed as a power of 2 is 2 to the power of 2. So there's my shift value. So I need to move it left by 2 places. So 1, 2, and then all of these follow behind. 3, 4, bang, bang, there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And that's it. And let's have a look. So the top one is the binary for positive 6. Positive 6 times 16, well that's 96, and that's the binary for 96. Let's just double check that. So I've got a 64 plus a 32, yeah, look, that's 6 and that's 9, so that's correct. This one is the binary for 51 in blue. 51 times 2 to 1, or 2 to 1 is 2. 51 times 2 equals 102, and that's the binary for 102. Just make that a bit clearer. And then lastly, we've got the binary for 31. 31, what we're doing it, timesing it by 4. 31 times 4, and there's the answer. Which is 31 times 4. 4 ones are 4, 4 threes are 12. Yeah, 124.